what if you need to factor something that doesn't just start with an x squared? It has some number in front, like a 3. What would we do then? So the first thing that I always want to try, always, I'm going to want to start by seeing if there's something that I can factor out of all of the terms, called my greatest common factor, or GCF. So in this case, I have 3, 12, and 63, which are all divisible by 3. So I'm going to take that 3 and factor it right out. So if I take 3 out, the first term becomes just x squared. The 12 becomes 4. And the 63 becomes 21. And now, although there's this 3 kind of sitting out front, I'm still going to factor in the same way that I did before. I will be looking for two numbers that multiply to negative 21, add up to negative 4, and I can do this because now I don't have a number in front of the x squared, at least not within the parentheses. So, what is going to multiply to 21 and add up to 4? In this case, I have a negative here, so one of my numbers will be negative, the other will be positive. And 21 is 3 and 7, so if I pick a negative 7 and a positive 3, they will add up to negative 4. So I will get x minus 7 and x plus 3 as these two factors that will multiply to x squared minus 4x minus 21. And the 3 is just going to stay out in front. I can use this same technique, even though there isn't a number out front. This looks like x cubed, but if I notice that there's an x, and an x in every term, I can do that same thing and factor out just an x. Now I see here, I have this same situation where I'm starting with just a plain x squared. I'm going to be looking for two numbers that multiply to 150, add up to 25. 10 and 15 will do that for me. So my final answer still has the x in front, and now I'm going to get inside x plus 10 and x plus 15. And there's my final answer here. Now, if I look at number 3, this trinomial does not have a greatest common factor, or rather its greatest common factor is 1, so it's not useful to pull that out. So what do I do in this case? Well, I could use the trial and error method, which is basically to say, well, what happens to get me 3x squared? Well, 3x and x is going to multiply to 3x squared. So 3x squared could be 3x times x. And negative 10 could be, let's see, I could have negative 2, positive 5. I could have positive 2, negative 5. I could have negative 1, positive 10. Or I could have 1 and negative 10. So let me see, with trial and error, which of these solutions might possibly work. So I'm just going to go down my list. What if I had 3x minus 2 and x plus 5? So in this case, when I multiply it out, 3x times x gets me 3x squared. 3x times 5 gets me 15x. Negative 2 times x gets me minus 2x. Negative 2 times 5 gets me minus 10. Well, plus 15 minus 2 is going to get me to 13, which is not this middle term. So this one is not going to work. Let's try again. What if I do these in the other order? Putting the 5 with the 3x and the minus 2 with the x. So I could have 3x plus 5 and x minus 2. So 3x times x will get me to 3x squared. 3x times negative 2 will get me to minus 6x. 5 times x will get me to plus 5x, and 5 times negative 2 will get me to minus 10. And this one is the thing I was looking for. So I know that this really was the correct answer here. Now, if I look through the list, there's only really one way to split up my 3x squared. But I had 4 ways to split up my negative 10, and in each of those 4 ways, I could have put it with one part first or the other part first. So I really have 8 possibilities that I might be trying. We got lucky here in getting it on the second try, but I want to show you a method that's going to work where we don't need to do trial and error on every single possibility. So here, for this one, I'm going to set up the same diamond problem that we've been doing, but instead of putting minus 10, I'm going to take both of these numbers, multiply them together, and that is going to give me the number that I put on top. So 3 times negative 10 will give me negative 30, and then this middle number, there's really an invisible one there, is going to be negative 1. So I'm looking for 2 numbers that multiply to negative 30, but add up to negative 1. So in this case, negative means one of them's negative, the other one is positive when I multiply to a negative. So 5 and 6 are going to get me to minus 1 as long as I make the 6 the negative 1 and the 5 the positive 1. But this does not get me to my answer, right? My answer, this is the same problem as this. My answer was not x minus 6, x plus 5. Definitely not. So what do I do with these numbers? What I'm going to do is I'm going to use them to split up this middle term. So the 3x squared is going to get copied, but the minus x here in the middle is going to get split up into minus 6x and plus 5x, and then the minus 10 is again just going to be copied. So this is helpful because now I can look at each pair here separately. I have 4 terms, so I can break them up into pairs. Here I'm going to try and factor out a greatest common factor, in this case 3x, and that will leave me with x minus 2. And in this case, I can factor out a positive 5, and that will leave me with an x minus 2. I notice that I get x minus 2 in both parts. If I have split the middle term properly, this will always happen. So now, x minus 2 is the greatest common factor. And if I take x minus 2 out of the first term, I'll get 3x. If I take x minus 2 out of the second term, I'll get 5. So this is now my final answer. So let's try that again with a different trinomial. Here if I want to use trial and error, the 15x squared I could split up as x times 15x. I could split it up as 3x times 5x. The plus 4 I could split up as 1 times 4. I could split it up as negative 1 times negative 4. I could split it up as 2 times 2, or I could split it up as negative 2 times negative 2. So if I look at all the possibilities here compared to what I had here, I actually have more possibilities because each of these splits, right, is going to have a set of 4, in fact more than a set of 4, because I could put the 1 with the 15 or the 1 with the x. So here I'm going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possibilities. So the trial and error method, maybe we'll get lucky, but it's going to take a long time if we're not lucky. So in a case where these numbers at the beginning and end are not prime, then I highly suggest that you use the splitting the middle term method. If one of these numbers was prime, like here with 3, then the trial and error method can be very fast. So let's instead split the middle term when solving this. So remember that the 15 and the 4 together are going to give us this number up top. 15 times 4 is positive 60. And then the number in the middle is going to give us the negative 16 on the bottom. So I'm looking for two numbers that add up to negative 16 and multiply up to 60. So if I'm multiplying to a positive, they have to have the same sign. Adding to a negative means that both of them will be negative. In this case, 6 and 10 will get me to a sum of negative 16. And again, that does not give us our final answer because there was a number in front. So instead, we're going to use these numbers to split up this middle term. So 15x squared stays exactly the way it is, but instead of minus 16x, I will have minus 6x and minus 10x, and I will copy the 4. So that 16 gets split in 2. Now I can look at each of these separately. Here, 15 and 6, I could pull out a 3. And x squared and x, I can pull out an x. So if I pull 3x out, I'll be left with 5x minus 2. And in the other side, I don't want to start with the negative, so I'm going to factor out that negative. And I can pull 2 out as well. If I take negative 2 out of this, I'll get positive 5x. If I take negative 2 out of 4, it'll give me negative 2. And again, these match. So I can pull them out as the greatest common factor. And what I'm left with from the first piece is 3x, and from the second piece I'm left with negative 2. So here is my final answer for this polynomial.